Starting in Maya 2016 Extension 2, you can use Maya's integrated Mesh toolkit to apply all sorts of procedurally animated effects to reproductions of objects. These are especially useful in motion graphics, where abstractions of simple shapes are often preferred over high-fidelity models of real-life objects. You can then export these animations to software like Adobe After Effects for further finishing. In this series, we'll show you the end-to-end workflow of how to create the futuristic UI shown here. From a pixelated map of the Earth, to an animated ring and plexus effect to dress it up, as well as a UI that follows the camera as it moves. We'll then show you how to export these effects as individual layers to Adobe After Effects to finish them into a final scene. Starting in Maya 2016 Extension 2, you can use Maya's integrated Mesh toolkit to apply all sorts of procedurally animated effects to reproductions of objects. In this movie, we'll show you how to create the pixelated globe for our futuristic UI. Before you can start using Mesh, you should make sure the Mesh plugin is loaded. In this tutorial, we'll build all our Mesh effects out of a simple cube, which we'll create via the polygons shelf. Although you can create a Mesh network using any object, a cube is simple and will ensure the best performance. Let's create our first Mesh network by selecting it and going to Create, Mesh, Create Mesh Network. Clicking the small box brings up the Mesh options. Take note of the geometry type. You can either create instances, in which case Maya will draw our cubes as though they exist in the scene without them actually existing, or actual mesh reproductions, in which case Maya will create actual copies of our original cube. The former is better for performance, but is not as versatile as the latter. Since our basic shape is so simple and shouldn't incur too much of a performance cost anyway, make sure this is set to Mesh. As you can see, Maya has turned our one cube into 10 and spaced them out neatly in a line. This is Mesh's default distribution. To modify this, open the Perspective Outliner view. The outliner provides us with a list of objects in our scene. As you can see, this includes the Mesh network's waiter, which acts as the hub for all its effects. To see what kinds of effects we can apply to this network, open the Attribute Editor. The Attribute Editor shows you all the options and related objects to whatever you currently have selected. In this case, it shows us the various effects you can apply to this Mesh network because we have the waiter selected. Each time you apply one of these effects to your network, imagine it as though you are adding another node to a stack. The order and combination of the effects determines the final look of the scene. You can find a list of what each of these nodes does in the Maya documentation. You can also see what effects are currently being applied via the tabs at the top of the Attribute Editor. Notice that our network already has a distribute node applied to it. Mesh always adds one of these automatically because it needs to know the manner in which the objects, in our case the cubes, will be laid out in the scene. Maya also automatically added a color, time, and repro node. These are specific to the mesh geometry type we chose earlier. Although they are important, we won't need to modify them. For now, just click on the Distribute tab. Here you can see all the settings related to the way our cubes are distributed. In particular, note that it's generating 10 points in a straight line, spaced such that the total length is 20 units on the x-axis. You can of course change these settings to affect the linear distribution by changing the number of points, which axes to distribute along, or even adding some scale or rotation further along the distribution. Or you can change the distribution type for an altogether different effect, such as radial, spherical, and so on. Each of these has their own sections and distribution-specific settings. Some, like radial and spherical, work on the number of points you currently have in the scene, while others, like grid, require that you input specific dimensions instead. However, all of these are affected by the options in the Strength section. Notice how adjusting the different strength sliders changes the distribute node's effect on our cubes, either all at once or individually, to produce some pretty neat results. Now that we've gone over the basics, let's use Mesh to start creating our UI, starting with the representation of Earth at its center. If you look closely, you'll notice that the Earth in this example is made of cubes, just like the distributions we've been working with. To recreate it here, we'll create a sphere and then stick the cubes to it in the shape of the continents using a 2D picture of the world. Create a sphere by clicking the sphere icon in the polygon's shelf. The reason we can't see a sphere yet is because it's too small. So go to the P-Sphere 1 tab in the attribute editor to scale it. Let's make it 40 times larger. Now select the Mesh Waiter node in the outliner again. This time we'll go with a mesh distribution type, which allows us to use a helper object to manage the distribution. You might be wondering why we didn't just choose a spherical type. This is because a guiding mesh will give us better control over the precise distribution, as you'll see in a moment. For now, scroll down to the Mesh Settings section. We need to tell Mesh to use our new sphere as our guide, so middle drag it from the outliner to the Input Mesh section. If you look around the sphere, you can see that cubes are now sticking to it, and even if you add more points, the new cubes will as well. However, the distribution is random because our method is set to scatter. Instead, change it to face center. This puts a cube at the center of each face on the sphere, which you can see better if you turn on Maya's wireframe on shaded mode. We clearly need to increase the number of points to cover the whole sphere, but rather than just guess at how many we need, we can just turn on the Flood Mesh option. This automatically puts a cube at the center of every face. Without even mapping out the continents yet, it's pretty clear that this isn't going to be enough cubes to map out much of anything. We need to drastically increase the number of cubes in our distribution. Select the sphere again, and this time go to its Polysphere tab in the Attribute Editor. This is where all the settings for the sphere are located. Currently, the sphere is composed of 20 faces around and 20 faces up. Change this to 140 and 100 respectively. Now you have many more cubes to work with. The last thing we need to do is map our continents by hiding any cubes that would represent water. Select the Mesh Waiter again and go back to the Mesh tab. Since we need to hide cubes, we're going to add a visibility node to our network. If you adjust the sliders, you can see that we can make the cubes randomly visible or via their ID. But to hide them in a specific pattern, we'll need to use a strength map. The strength map field allows us to assign a shader to control the strength of our visibility node's effect. Think of it like a drawing where anything white will appear visible and anything black will appear invisible. To assign such an image, click the button next to the attribute. In the Create Render Node window, select File. This connects that attribute to a new file node. To assign the file that this node will represent, click the folder icon next to Image Name, then select the black and white world map included in this tutorial's scene files. The pattern of cubes on the sphere definitely changes, but this doesn't look anything like the Earth. That's because Mesh isn't sure how to apply that 2D image to this 3D object yet. Select the Mesh Waiter again and go to the Visibility node. Just like we're using the sphere as a helper object for the cube's distribution, we'll also use it as a helper for their visibility. So middle drag the sphere into the Map Helper field. Now you can see that the cubes fall in line with the world map. To make it even clearer, turn off wireframe on shaded, then select the sphere in the outliner and press Ctrl H to hide it. This leaves you with a floating pixelated globe. Note how easy it is to change. If you select the sphere in the outliner and increase the number of faces, the Mesh network updates accordingly. You can also go back to the Mesh Network's Distribute tab and play with those same strength values we tried earlier to get neat effects quickly and easily. That's a good start for now. In the next movie, we'll show you how to layer a plexus sphere and ring over this globe. We used the Mesh toolkit to build a pixelated replica of the Earth. In this movie, we'll overlay a plexus effect over top of the planet, as well as a few small bolts, and then form a ring around it. You can either continue working from your previous file, or load the provided Mesh UI Part 2 Start, provided in the link in the description. Before creating a plexus effect, let's use what you've already learned to create some random little pipes to float above our globe. This time, rather than a cube, we'll start by creating a polygon pipe from the polygons shelf. In the attribute editor, go to the Poly Pipe tab. Reduce the subdivision axis to 6 to give the pipe a more nuts and bolts-like appearance. Also set the radius to 1.5, height to 0.5, and thickness to 0.75, so it appears like so. Go to Create, Mesh, Create Mesh Network to add it to a mesh network. Now if you look at the outliner, you can see we have two. Since you don't want to get these confused, now would be a good time to rename these objects to something more meaningful. Double-click Mesh 2 and rename it Mesh Bolts. Do the same for Mesh 1, naming it Mesh Earth. While you're at it, rename their respective ReproMesh objects as well, since these represent the actual geometry for each respective network. Finally, rename pSphere1 to EarthSphere, pCube1 to PixelCube, and pPipe1 to Bolt. With that done, select the Mesh Bolts waiter. Like the previous movie, we'll use our Earth sphere as a guide to distribute these bolts, so go to the Distribute tab. Set the distribution type to Mesh, then scroll down to the Mesh Settings section and middle drag the Earth sphere object from the outliner to the Input Mesh field. Increase the number of points to 50. The scatter method is appropriate for this effect, but notice how some of the bolts are getting lost in the cubes that make up the continents. We don't really want this to happen, plus we want a more layered look anyway, so increase the Push Along Normal attribute. This pushes the bolts out in the direction of the helper sphere's face directions. A value of 4 looks pretty good. And as always, you can tweak the values in the Strength section to change the effect as well. In particular, you can use small alterations to the Random Strength attribute to subtly change the height of different bolts. You can also use the Random Seed value to change the randomization of the bolts over the globe's surface. With that layer complete, let's add our plexus sphere over top of it. Originating from a Latin word meaning network or weave, a plexus effect is essentially just a random assortment of points connected by trails. First, create a new cube. We could actually reuse our existing pixel cube if we wanted, but we'll want this one to be at a different scale than those. To that end, go to the Polycube section of the attribute editor and change the cube's width, height, and depth to 0.5. Now create a new mesh network for it and rename it Mesh Plexus along with its ReproMesh. Follow the same steps you did with the bolts to distribute the cubes around the globe. This time, set the number of points to 200 and push along normal value to half that of the bolts, so that these new cubes appear halfway between the Earth and the bolts. You can also turn off Calculate Rotation, since they're so small that you won't even notice their orientation. These small cubes will serve as the connection nodes for our plexus effect, but we need to draw the trails between them now. You can do that by adding a Trails node from the waiter. Upon first adding this node, nothing seems to happen. That's because the Trails node is set to Trails, which only displays trails when the network objects are in motion. Instead, Switch to Connect to Nearest. This setting will draw trails from a point to a certain number of other nearest points, rather than by motion. Increase the trail scale to make the lines easier to see. However, at only one connection, the plexus effect is a little thin, so increase the count value to 3. You'll also need to increase the max trails to 500 to accommodate all the extra trails. Then adjust the trail taper graph so that the trails remain the same size from start to end. You may need to readjust the trail scale after to compensate. To smooth out the jagged edges in the workspace, turn on multi-sample anti-aliasing. And that's a quick and easy plexus effect completed. To round out the layers of our globe, let's add a pixelated ring around it. In this case, we will reuse our pixel cube. Create a new mesh network for it, and name this one Mesh Ring. This time, we won't use the Earth sphere as a guiding object at all. Instead, set the distribution type to radial. Increase the number of points to 250, then scroll down to the radial settings and set the radius to 55. Also set the radial axis to ZX to change the direction to the ZX plane. That's our base ring already done. Next we need to add some layers to that. We can do that by replicating our existing ring over and over using a replicator node. In the Replicator tab, set the number of replicants to 6. Mesh replicates the ring with its default values, but that's not exactly what we want. Looking at the settings, you can see it's actually moving each replicant -2 units in the z-axis. However, what we actually want is for the ring to scale progressively bigger. So set the offset position z to 0. Then go to the Scale section and scale the replicants in the x and z direction by 0.13. Now we get a much more full-looking ring, but it's kind of boring like this. Luckily, we can use the Strength section to fix this. In this case, just adjusting the random strength slider gives our ring these nice peaks and valleys. The last thing we'll want to do is transform the rotation of this ring a bit so that it isn't so flat compared to the Earth. To do so, we need to add a transform node. Give the ring an x rotation of 25 degrees and z rotation of 10 degrees. Now the ring has a nice lean to it. That pretty much finishes up the layers of our globe, though you can feel free to adjust or add even more effects as you please. In the next movie, we'll show you how to animate these